The next talk is in charge of Alfio Zambon, and the title is Chemical Reactivity and Substance as Spectrum.
Okay.
Okay.
Since my English is not very good, Andrea will help me in the presentation.
Okay. First of all, good afternoon to all the symposium attendees. In this presentation, I will be introducing the chemical reactivity and substance as spectrum. I would like to start by saying that the following is a work in progress. And also begin the presentation by citing Jorge Luis Borges in an excerpt from his short story, The Aleph, that will serve as a topic starter. The Aleph was probably 2 or 3 centimeters in diameter, but universal space was contained inside it, with no diminution in size. The description of the Aleph could be interpreted as a narration of the perception of space abstracted from time. We will revisit this idea later. Throughout this presentation, I will discuss the status of chemical substance framed within a chemical reaction. To do so, I will be based on a philosophical framework inspired by Kant. Kant, without denying the existence of a world independent from the subject, differentiates between the phenomenon and what underlies it, the noumenon. To explain how appearances arise, Kant proposed an original conception of space and time, not as properties of things, but as a priori structures that enable us to configure the world. Kant stated that space and time are not inherent properties to the world itself, but to the way that we perceive the world. The forms of sensibility, space and time, are a priori conditions to representations. To think on representation, the understanding requires categories. Categories are a priori conditions to think the objects. Categories are divided into 4 groups: quantity, quality, modality, and relation. Now, let us consider the concepts of substance and element along the history of thought. In pre-Socratic philosophy, the concept of element referred to what is primary, fundamental, and persistent, as opposed to what is secondary, derivative, and transitory. At the end of the 18th century, Lavoisier proposed an operational definition of element. He considered the elements as the final product of chemical analysis. The dual sense was revalued by Mendeleev, who affirmed that elements, in addition to being able to be conceived as simple substances and also isolatable, are basic substances, unobservable. Frederick Panev in 1931 differentiated between elements as simple substances according to their phenomenological manifestations and elements considered in an abstract sense as basic substances. In this work, I will present a different notion of substance, but with some points of contact with Panev's proposal. In this work, I will propose a concept of substance as a phenomenon that it is perceived within space and time. Substance is a spectrum, enabling an infinite set of interpretation of the chemical phenomenon between 2 extreme forms. The spectrum limits are the perception of the manifested change in time abstracted from space, which generates the macroscopic temporal substance, MTS. The perception of the relationship between entities of geometrical representation manifested in space, abstracted from time, thus generating a geometric space substance, GSS. This slide shows a graphic with the proposal for this work. On the right, we see the perception of time, abstracted from space, that originates the macroscopic temporal substance, MTS. On the left, we see the perception of space abstracted from time that originates the geometric space substance. Both are the extreme forms of perception within the spectrum of the substance as a phenomenon. In this graphic that completes the ideas of the previous one, we can observe how, based on the conceptual synthesis by means of the categories of understanding, it is possible to set macroscopic chemistry, MC, or geometric chemistry, GC, as the limit forms of interpreting the chemical phenomenon, and atomic molecular chemistry as the primary form. From this proposal, it can be said that macroscopic chemistry as well as geometric chemistry both allow an accurate knowledge on the chemical phenomenon, yet limited because partial. Instead, the atomic molecular chemistry becomes a more powerful and comprehensive tool, but less accurate because approximate. The three approaches are complementary to each other and part of the same hierarchy, and allow to analyze aspects of the chemical knowledge from different points of view. It is possible to differentiate among the conditions of possibility of the objects involved with the experience and the concrete descriptions of a state of things at a certain time. This allows us to establish a distinction between material reaction and formal reactions. The material chemical reaction, MCR, consists of the interaction between macroscopic temporal substances and conformed macroscopic chemistry. The formal chemistry reaction, FCR, consists of the interaction between geometric space substances and conformed geometric that I will introduce here. Language is of a successive nature, therefore temporal. By making an abstraction from time, it is necessary to order the objects participating in the experience, elements or compounds, in a different order from the one in which they naturally appear during the reaction, and by doing so, decoupling the order of appearance of the entities involved in the reaction with the reaction that is under analysis. When representing a chemical reaction, the mass number, the molecular number, or another relevant number can be set as the order parameter. Chemical reaction will be represented by a concentric circles diagram, where the reactant entities will be located, and lines named reaction path will be drawn to connect them and to represent their interaction. The order in the concentric circles diagram from the periphery to the center is as follows: reaction medium, reactant entities, intermediate entities, convergence nodes, and lastly, the center. The group of circles is considered as the reaction coordinates in space, in contrast with the traditional reaction coordinates that locate entities in time and corresponds with the macroscopic chemistry. In each circle, entities are ordered accordingly to their mass or atomic number, so that the maximum coincides with 2p, and the rest is located proportionally. The higher value corresponds to a convergence node that is in the inner circle. The order resulting from the union lines is decoupled from the order in which the entities appear in the molecular reaction expression. Each entity has a projection related to its energetic nature. Concrete chemical meanings could be found from geometric relationships. In some cases, like reaction heat calculated from the heats of formation, analogous values to those obtained using a traditional method could be found. Reaction coordinates in time. This slide shows the reaction coordinate versus energy. It is possible to interpret it as a reaction coordinate in time, describing the chemical phenomenon from a macroscopic chemistry perspective. Reaction coordinate in space. The concentric circles diagram is presented here. Keep in mind that reaction medium is painted blue, reactants in green, intermediate entities in yellow, and convergence nodes in red. Circles have their corresponding projection to an energetic parameter. Next, we present the representation of some reactions. For example, hydrolysis of fuel esters. In this slide, we see the reaction which has a tetrahedral intermediate in equilibrium. The reaction coordinate, which I named in time in this work, is shown here. The reaction coordinate in space is shown in this slide. Molecular numbers are used as parameters. The convergence node has a value of 57, keeping in mind that as the maximum, it orders the rest of the values. Sulfuric acid dissociation is shown here. Note that all species are interconnected, allowing the simultaneity of the equilibrium of a polyprotic acid to be visualized, which is usually treated as successive equilibria. The reaction mechanism of an esterification and its representation by a reaction coordinate in space is shown here. Mass numbers are used as parameters. The convergence nodes are 79 and 93. They interconnect the 9 species that participate in the reaction. 93 is maximum and corresponds to the reactive intermediate. All the other species are ordered proportionally to their mass number. Note that the order of the species is not related to how they appear in the reaction. In every chemical equilibrium case, the understanding of a reaction in terms of geometry allows to avoid the logical paradox caused by the bidirectional causality. The traditional approach introduces a logical paradox, the equality of the rates of the direct and inverse reaction, where the entities are both reactants and products, can be interpreted as being before and after at the same time. At the geometric level, since the phenomenon is perceived as abstracted from time, the equilibrium can be interpreted as a geometrical relationship, a timeless phenomenon. This approach is compatible with the spatial temporal interpretation of a statistically significant number of molecules that collide and maintain equal reaction rate, and with the macroscopic perspective where the relations between matter understood as things do not change or seem not to change. The 3 visions are cohesive by the substance itself. This slide shows a reaction as an example to visualize the chemical equilibrium as a geometric expression. The 4 entities have a projection that represents a magnitude analogous to the free energy. When the mean values between each pair of species coincide, a slope 0 line, green dashes line in the graphic, can be drawn. This represents the equilibrium condition as a simultaneous relationship, avoiding the logical difficulty and bidirectionally causality. In gray, a volume formed by the intersection between the values of the 4 participating species, the convergence node, and the reactive intermediate can be observed. This volume is unique for each reaction, and its relationship with the external cylindrical volume could provide information on the relationship with the reaction medium. This last consideration is merely speculative.
5 minutes, Andre.
Thanks. In this work, I propose the notion of substance as a phenomenon perceived in a Kantian sense of space and time. This results in an infinite set of ways to interpret the chemical phenomenon between 2 extreme forms. The substance in time abstracted from space, macroscopic temporal substance, the substance in space abstracted from time, geometrical spatial substance, All forms have the same hierarchy and allow to visualize different aspects of the same phenomenon, or the same aspect, but from a different perspective. Using categories of understanding as a starting point, we have geometric chemistry and microscopic chemistry that show complementary perspective. Chemical equilibrium is an aspect that could be enriched from the geometric perspective. It is important to say that this work shows an initial proposal and that further development is required. Finally, I will finish this presentation by citing Borges, an excerpt from Avatars of the Tortoise. We, the undivided divinity operating within us, have dreamt the world. We have dreamt it as firm, mysterious, visible, ubiquitous in space and durable in time. But in its architecture, we have allowed tenuous and eternal crevices of unreason, which tell us it is false. Thank you everyone for your attention, and comments and questions are welcome.
Thank you for the talk. I remember you, if you want to ask a question, please indicate in the chat and wait your turn to speak. Michelle Frian have the first question, right?
Hello. Yes, this was very interesting. It was very rich, and I'm not sure that how much of it I understood really. But in your stride, but just a small thing, in your one of the last slides, you had this notion of chemical equilibrium, and you were showing a geometric conception of the molecule. But you also talked about, and you said that this geometric conception doesn't include time, but then you drew this dashed line, the green line, to show simultaneity. And simultaneity is usually thought to be a temporal notion. So maybe you could help me understand better.
Lo que está diciendo es que si estamos hablando de que es sin tiempo, ¿por qué en la línea verde que estamos mostrando eso quiere entender si eso tiene relación o no con el tiempo? La de la slope 0, en el gráfico de 3D.
¿En el gráfico de 3D?
Sí.
Cuando hablas de simultaneidad, Alfio, lo que Michelle está diciendo es que el concepto de simultaneidad también involucra tiempo. Tal vez es un concepto que es una palabra que no habría que usar.
Volver. Eso.
Sí, a ver, sí, involucra el tiempo, digamos, abstraído del tiempo. En el sentido,
tiempo abstraído del tiempo?
No, el espacio abstraído del tiempo, digamos, en el sentido de espacio y tiempo como forma de percepción. O sea, lo que hacemos cuando representamos el fenómeno geométrico es abstraernos del tiempo.
What he's explaining is that in this approach, it is abstracted from time. That this is only a geometrical representation. It does not involve time.
Yes. En algún sentido se podría considerar que el tiempo es constante.
It is considering time as a constant.
But then I don't understand what simultaneity means.
El tema es con la simultaneidad, porque como nosotros decimos, ya sé, porque acá estamos diciendo en el equilibrio poliprótico, me parece que es esto. Are you referring to this slide about the equilibrium?
Not this one that I see. There was one with a green dashed line.
The green dashed line represents a slope 0.
Las sustancias participantes.
Sí. It's the relation between the participant reactants. Okay. This allows to create a volume later that will be compared in matters of energy.
Okay, it wasn't this slide. Maybe I just misheard what you said. That's all.
You're referring to this one, the green line, this dotted line here.
Sí.
this line allows to create volumes that, since this work is still in progress, it needs further development, and it will be related to the to energy parameters.
But doesn't mean simultaneity.
Yes, it doesn't mean simultaneity.
I misheard in that case. I'm sorry.
It's okay.
Yes, thank you.
Okay, another question. There are some positive comments on the chat. And Bruno Pastoriza have a question. Bruno, you can answer.
Hello. When we talk about the representations, and I think this geometrical representation is a form to explain or facilitate the idea for the other who are willing to explain something. And when you show the kinetic reaction, the coordinate of the reaction, and says that there is a time projection, and compare on the other hand with the progress of reaction, the proton reaction, etc., and says that this geometrical reaction can be used to explain these processes. In which way this geometrical representation can explain more than these separated relations? Explain more, for example, the kinetic reaction and the molecular reaction. I think I didn't understand the contribution of this geometrical explanation in relation to others, these other two possibilities.
Okay, let me see if I understood you correctly. You want to know in which way the geometrical approach helps to understand the polyprotic acid dissociation in something that a reaction that has more than one step that appears simultaneously.
More, si yo tengo dos representaciones, si yo tengo la representación geométrica, y si yo tengo esta relación con la representación de la coordenada de la relación, sí, y tengo la representación de la protólisis, de la representación que se va en una dirección que es más de la estructura molecular, por un lado, y al otro lado yo tengo la representación del tiempo con la cinética. Y la representación geométrica, yo no comprendí la contribución que esta representación geométrica trae para que va más allá de estas dos representaciones. ¿De qué contribución, qué diferencia hay con esto?
La macroscópica sería la representación en el tiempo. La geométrica sería una especie de oposición a la macroscópica, sería la representación en el espacio. Y la atómico-molecular sería en el espacio-tiempo. En algún sentido, las tres son complementarias.
What he's saying, let me share the presentation because I think we have, maybe the graphic will help with the explanation here. Okay. No, más arriba, donde tenés el cuadrito el cuadro de las I think this slide may help with the contribution of geometric chemistry, because macroscopic chemistry is the one that is abstracted from space, and geometric chemistry is a proposal for abstraction from time. And what we are normally working with is what it's in the middle. That's what you're referring with the cinetic approach that happens with both time and space changes. In this case, it's complementary. Yes, okay. Since it's in its early stages of development. Sí.
So the idea is not to substitute this representation, but
no, it's not to substitute. It's complementary.
Okay. It will more information.
Yes.
Okay, Olympia, do you want to ask?
A little comment to complement the idea of space, abstracted of space and abstracted of time. Space and time are forms of sensibility in Kant, but also you can find something in the categories. In the categories of relation, you have causality and you have subsistence. In a certain sense, the category of causality has to be used in the case you are thinking in process in time, where you have causes and effects. But subsistence is a category that I think that is very useful for equilibrium, where you need to explain relations abstracted of time, I mean, not as a successive, but at the same time or without time. So I think that this idea can be also conceptualized from the categories. And this is my suggestion.
Eric Serri?
Yeah, thank you very much, Alfio and associate friend, wife.
Andrea.
Just a question. You mentioned there was a paradox relating to equilibrium reactions on the page where you had A plus B gives C plus D. What is the paradox? Please explain what you see as a paradox.
La paradoja.
Claro, la paradoja esta de que
la causalidad bidireccional, ¿no? En la cual parecieran, digamos, tanto lo que llamamos normalmente productos reactivos o izquierda y derecha, estar tanto antes como después.
It's in relation with the, it seems that when we write the equilibrium this way, it seems that reactants and products are present both at the same time. They are simultaneously, but something has to happen before and then something after. This is the
from my previous conversation with Alfio, I think it's cause and effect that are being confused here. Just one second. Yeah, that's what he meant, I think.
Yeah,
if I understood you correctly, Alfio. No sé.
Come again, because it was a lot of noise.
Creo que el problema es que la causa y el efecto están simultáneos en esta representación, ¿no? ¿Es correcto? No, the cause and effect are simultaneous in this representation. That's what
en la representación propuesta no hay idea de causa ni de efecto, sino hay de simultaneidad. Se elimina la causa y el efecto.
So it implies to the viewer that the cause produces the effect, but the effect produces the cause, kind of thing. It's a circular type of reasoning, right?
It's abstracted from that idea of cause and effect. It's independent of cause and effect idea.
Because chemically speaking, it's perfectly possible to begin that reaction with A, B, C, and D. I mean, does that come into it? Is that the worry? That typically one would start with only A and B? And therefore, I'm just trying to get my head around this.
Lo que se les complica es entender por qué, si esto es perfectamente posible en química, empezar la reacción así, ¿Por qué estás proponiendo?
Porque en el equilibrio existe la idea de equilibrio dinámico. Y acá, digamos, sería plantear desde otra óptica, así como en lo macroscópico, existe la idea de permanencia, o sea, de un cambio no aparente. En lo geométrico existe también una idea de permanencia en cuanto a una correspondencia geométrica.
Okay.
¿Se entiende?
Kind of. It's because in the idea of dynamic equilibrium, the geometrical approach. De vuelta.
El abordaje geométrico existe, digamos, una simultaneidad porque se da en el espacio abstraído del tiempo. Así como en lo macroscópico, aparentemente no cambia nada, pero no cambia nada en el tiempo. O sea, no cambia nada en el espacio.
It's a different perspective.
Sería lo complementario de lo macroscópico.
It's complementary to the macroscopic approach, but it is shown in a different way. One is abstracted, it's related to the change in time in the macroscopic approach, but in the geometrical approach is independent of this change in time.
Okay, thank you.
Okay, I think that we can continue this this discussion in the coffee break. There is only one question more, and please, Christian Lopez, be short because we are on time.
Substance?
Okay, I will try to be short. Thank you, Alfio, for this beautiful talk. Just one more philosophically oriented question about the notion of substance as phenomena. I didn't really get it, what you mean by the substance of phenomenon or something like that. Could you please explain that for me a little bit further?
Quiere saber el tema de la sustancia como fenómeno.
La sustancia...
Con que le expliques ¿por qué decís que la sustancia como fenómeno? Eso es lo que viene de Kant.
Lo que digamos
pero decirle, aclarar que sustancia no es el concepto filosófico de sustancia, es el concepto químico de sustancia.
El sustancio químico de sustancia, claro.
Okay.
Entonces, es complementario en el espacio, en el tiempo y en el espacio-tiempo. Pero son visiones no complementarias, digamos. O sea, intenta ser complementario. Como actualmente se veía en lo macroscópico con lo atómico molecular, ahora se agrega lo geométrico como contraparte de lo macroscópico.
Sí, pero él estaba cuestionando el tema de sustancia, el concepto de sustancia.
No, es sustancia química. Sí.
Yeah, the chemical approach, not
pero es probable que muchas gracias porque puedo tener que aclararlo en otro país.
It should be just very, very brief, because in Kant, usually substance is what remains. So it's in Kant a contradiction to talk about the substance as a phenomena, because the phenomena is what is determined and also changed. So that's why my confusion. But if you say that is the notion of substance as is employed in chemistry, so that's fine.
Okay, we're in time.
Thanks.
So we can continue in the coffee break. Thank you, Alfio and Andrea, for the talk and for the people that participate with questions.